6.3 Multiplication of a vector by a scalar. Now scalar is just a number. So for the vector Ka, where K is a scalar and vector A is a non-zero vector, if K is larger than 0, such as 1, 2, 3, 4, 5, then Ka is in the same direction with magnitude K multiplied by the magnitude of vector A. Now remember, the magnitude of vector A is no longer a vector. It is a scalar now, or a number. So that is why we can multiply a number with another number. So let's say we have vector A here, and let's assume the magnitude of vector A is 1. So what is 2 times the vector A? All we have to do is we just take 2 multiplied by the magnitude of vector A, which is 2 times 1, we will get 2. The same goes for, what if we want to find half of vector A? All we have to do is just take 1 over 2 and multiply it by the magnitude of vector A, which we will get 1 over 2 also. Next, if K is lesser than 0, so it could be -1, -2, -3, then Ka is in the opposite direction with magnitude. Now remember here, absolute value of K multiplied by the magnitude of vector A. Now why do we absolute value the K in this scenario? Because imagine the length of something. Even if the length is in the opposite direction or any direction, the length will still not change, right? The length will always be constant no matter what direction you flip it in. So it's the same goes as a vector. That is why we need to absolute value the K. So if you want to find negative the vector of A, all we have to do is just multiply the -1, absolute that, and multiply it by the magnitude of vector A, which we will get 1. And the same goes as -2 vector A. All we have to do is just multiply -2, absolute value it, multiply by the magnitude of vector A, which we will get 2. And you can see it's the same as above because the length is the same, even if the direction is different. So again, this is same for -half vector A, which the length of -half vector A is the same as half vector A, which is 1 over 2. Note, if you multiply a vector by 0, you will get the 0 vector. For example, if you multiply 0 by vector A, you will get the 0 vector. Now, be careful here, because the 0 vector is not equal to 0. The 0 vector still has some kind of direction, but it's technically 0. Yeah, the length is 0, but it still technically has some information left. So it's not totally equals to 0. Next, if 2 or more vectors are non-zero scalar multiples of the same vector, then all these vectors are collinear. Now what does that mean? So let's say we have a vector A here. What if we want to find 2 vector A? So 2 vector A must be the same direction as vector A, right? Because 2 vector A is just 2 times the length of the original vector A. So this would be 2 vector A. And let's say we want to create a vector B, which is equal to 2 vector A, or the length of 2 vector A. So vector B will be somewhere here. Now, since vector B has the same length or same magnitude as vector 2A, we can actually put B on top. We can actually put B on top of vector 2A, and it will be the same because vectors can move. And if we move it on top, it will become the same because they have the same direction. And if they have the same direction and they are on top of each other, then this means that they are collinear. So that's why collinear is used interchangeably with parallel. It can also mean that it is on the same line. Linear dependency. If vector A and vector B are collinear, then vector A equals K vector B. Now K, as we just learned, is a scalar multiple of a vector. So going back to our example here, we said vector b is vector 2a, right? And vector 2a is just 2 times the length of vector a. So technically vector b is indeed 2 vector a, and that is why we put it together, and that is why it is collinear too. And again, if k is larger than 0, they will have the same direction. If k is less than 0, they have the opposite direction, same as what we learned before. Note, if it is stated that the angle between two vectors is theta, it is assumed that the vectors are placed tail to tail with theta between them. Now what does that mean? That means if there is an angle between two thetas, the thetas are arranged tail to tail, like this. And the theta will be in between them. If you recall, this is the tail to tail method of adding vectors. And we cannot, and it is not assumed, it isn't cannot, it's just not assumed that the vectors are arranged like this. So no, this is incorrect, because it is assumed that the vectors are arranged like this always to create some consistency. Now, moving on to unit vector. Unit vector is just a vector with a magnitude of 1. So if it is given that the magnitude of x, vector x, is 4, then the unit vector for vector x would be just 1 over 4 multiplied by vector x. So in general, we can say the absolute value of 1 over x multiplied by vector x is the unit vector. Next, if vector x and vector y are unit vectors and make an angle of 30 degrees, calculate the magnitude of 2 vector x minus vector y and determine the direction of 2 vector x and minus vector y. So be careful here. Look, if there is an absolute sign between here, that means they are looking for the magnitude. And if there is no absolute sign, that means they're looking for the direction over here. And since they say they are unit vectors, that means their magnitude would just be equal 1. So, oops, and the magnitude of y would also be 1 because they are unit vectors. So, since they make an angle of 30, as we learned before, we can draw them. We can draw them out. So let's say this is vector x and this is vector y. Remember, if they make an angle between them, the vectors are arranged tail to tail. So this would be 30. Let's just say this is vector x and this is vector y. Now calculate 2x. So what is 2x? 2x is just double of the x value. So it will be roughly around like this. 2x, 2 vector x. Now minus 2y. So if it's minus 2y, that means it's the opposite direction of y. So it would be something like this. Minus vector y. And so if you guys remember how to find the resultant vector, it is just from the tail of the first vector to the head of the second vector. So this is the resultant vector. So by using the cosine law, we need to find the length of this line and the length of this vector. Sorry, it's a vector, not line. So we know that the magnitude of vector x is 1. So if we multiply it with 2, then this would be 2 and this would be negative 1. But we remember, if we absolute value the negative 1 will become become positive 1, and positive 1 multiplied by positive 1 is just 1. So by using the cosine law, we can search for the resultant vector. So all we have to do is just plug everything in. And if the if you do the calculation correctly, it will equal to something approximately 1.24 units, because they didn't give us any units, so we are using the units as the unit. Next, we have to find the direction of 2 vector x minus vector y. But notice here, we don't have a compass, so what are we finding the direction of? Well, we can say that it is relative to another vector. So we can say that this resultant vector, we can find the direction of the resultant vector relative to vector x. So let's just put theta here. And and we are missing one more vector, but don't worry, it's very easy. Notice that this vector here and this vector here are parallel lines. So according to the properties of parallel lines, if this is 30, this is also 30. Now we can finally use the sine law to find the direction of theta. So sine 1 equals sine 1.24 over 30. And if you do the calculation correctly, theta will equal 23.8 degrees. So how do we write the concluding? So remember we must always write the conclusion statement. So it is 1.24 units. Remember the direction, 23.8 clockwise. Now we have to say clockwise from where, because it would be meaningless if you don't put a reference vector. So it is clockwise relative to vector x. And that's it for 6.3. Thank you for watching.